Welcome to quarter two of geometry. Congratulations for making it this far. Quarter one is difficult. Quarter two gets a little bit easier, getting the groove, and most students do better in quarter two than quarter one. All right, so the first standard is congruent triangles, proving or showing that triangles are exactly the same as each other. So one triangle is the exact same size as the next one. Like this example, that's what I'm asking you. Is triangle, that's what that symbol, triangle ABC. Now, a lot of students see this on a test and automatically think that's angle ABC. Don't make that mistake. This is not referring to this angle right here. That's angle ABC. This symbol means triangle. You're referring to the whole triangle, not just the angle. So that's a simple mistake that shouldn't be made, but it's made when you rush through a problem and don't take your time and read it closely. They think of this as an angle instead of a triangle, so don't make that mistake. They're similar, the symbols, but they're clearly different. Okay, so is triangle ABC congruent to triangle DEF? Well, if it is congruent, that means all corresponding parts are the same. All corresponding parts are congruent. So what does corresponding parts mean? That means all sides, the corresponding sides match up and the corresponding angles match up. So you're going to have 6 congruent parts. You're going to have one of these sides is going to match up to the side over here that's in the same position as the side over here. So how do you tell which side is supposed to be in the same position? Sometimes it's easy to tell just by looking at the picture, and you can tell that BC is going to match up with EF. But if it's harder to tell, you can look at the order of the letters in the triangle. BC are the last 2 letters in the first triangle, so that's got to match up with the last 2 letters in the second triangle, EF. So BC has to match EF. And I'm going to tell you that these 2 triangles are congruent because I drew them. So they look perfectly the same, kind of, if you can't see very well. All right, so BC and EF. How do we represent that they're congruent? We put a little tick mark on those. Okay, what other sides are going to match up? Should AB match up with DE or should AB match up with DF? Again, this one I drew so that it's kind of easy to tell just by looking at it. But if it wasn't so easy, AB is the first 2 letters in that triangle, so it's got to match up with the first 2 letters in the second triangle. So AB is going to match up with DF. Now, we can't just write one tick mark on here like we did on the first one, because if we do that, everything with one tick mark is equal. So we're saying that AB is the same length as BC, and a DE and EF, we're saying all 4 of these are the same length. And that's not necessarily true. All we know for sure is that AB is the same as DE, so we have to put 2 tick marks on that. So there you go. And then the last ones are going to match up, AC and DF. That's the first and the last letter, first and the last letter. So we'll put 3 tick marks on there. Now, if these were equilateral triangles, then we could put just 1 tick mark on all, because on an equilateral triangle, all sides are the same. So this would represent that all 6 sides are the exact same length, and if it's an equilateral triangle, that's true. This is not an equilateral triangle, so we need different tick marks for each pair of sides. So that's 3 of the corresponding parts. Now we need the other 3, the angles. And the angles, you could just use one letter in pictures like this. So which angle does C match up with? Does it match up with D, E, or F? Well, sometimes your second triangle is rotated. In this case, it's reflected, so it's not always easy to tell. So again, you look at the letters. Where is C? It's the 3rd letter. So the 3rd letter in your second triangle is F, so C has to match up with F. So instead of tick marks, we do a little arc mark, and we'll just do 1. And then the second letters are B and E, so we'll do 2 letters there. Those match up, not 2 letters, but 2 arcs. And then the last ones are, oh, we did the last ones already, C and F. Well, the first ones were A and D, so we'll put 3 there. Now, you don't have to have 1 tick mark on the first letter. Like, it doesn't matter if you have 3 tick marks here and 3 tick marks here, or 1 and 1, as long as these are the same amount and different than the other one. So what I'm trying to say is it doesn't matter which angle you choose to put the 1 tick mark on, which one you use to put the 2 tick marks on. Like I could have done this. Here's D, E, F. I could have said this was 2, this is 3, and this is 1, as long as I had 1 here, 3 here, and 2 here. So as long as they match, it doesn't matter how many you have, okay? All right, so those are the 6 corresponding parts, 3 angles that correspond and 3 sides that correspond. Now to prove that these 2 triangles are congruent to each other, we don't have to go through the process of showing that all 6 parts are congruent to each other. We only need half of that. We only need 3 of the parts. So let's start over on these tick marks. And I'm going to show you that you only need 3 to show that they're the same. So there's multiple combinations of the 3 that you could use. One of them that you can use is called SSS. And another one that you can use is called SAS. What that means is S stands for side and A stands for angle. So if 3 of the parts you have happen to be all 3 sides, that's enough to say for sure that those 2 triangles are congruent. So if I gave you a picture and I marked it like this and asked you, is that enough information to say that these 2 triangles are exactly congruent? You might say, probably not, because I don't know for sure that the angles are congruent and all 6 parts have to be congruent. So no, I'm going to say it's not enough because I don't know anything about the angles. And that would be a logical statement. However, this actually is enough to show that these 2 triangles are congruent. If you have all 3 sides the same, then automatically all 3 angles are the same. Think about it. If I gave you 3 lengths, say I gave you this pencil, this marker, and this cap, and said make a triangle out of it, it would look something like this, and that's the only triangle you can make. Now you could rotate it or flip it around, but as soon as one of these lengths gets longer or shorter, it's going to change the angle. You could play around with that on your own if you don't believe me, but if all 3 sides are the same, there's no way that this angle is different than that angle. They have to be the same. So basically all this is doing is saving you a little bit of work. If you get a question that says, are these 2 triangles congruent? You only have to find that 3 of the sides are the same. You don't have to worry about the other angles. 3 of the sides is enough to say that they're congruent. So this answer would be yes, they're congruent, and the reason would be SSS. So that's what the problems in today's do section are like. Yes or no, are these triangles congruent? And if you say yes, you have to give one of these 2 reasons. Yes, because all 3 sides match up. Or yes, because 2 sides and an angle matches up. That's the next one. Now, 2 sides and an angle is a little bit more specific than just 2 sides and an angle. I know SAS includes 2 sides and an angle, but it includes the angle in between the 2 sides. So what do I mean? Let me draw that picture again here for you. So you've got this and this back to the beginning. 2 sides and an angle with the angle in between the 2 sides. Well, here's 2 sides. Say you've got those 2 sides. You know those 2 sides match up these 2 sides. So you're almost there. You almost have SSS. If we could just show that these 2 sides are the same, we'd be done and say those triangles are congruent because of SSS. But let's say for some reason this problem, we just can't figure out the lengths of those 2 sides. We can't say for sure that they're the same. So we're not going to be able to use SSS. We have another way to do this, and that's SAS. If we could prove that one of these angles are the same, then that would be enough. But it has to be a specific angle. It can't be any one of these 3s. What I mean is, if you could figure out that C is congruent to F, you got 2 sides and an angle. However, that is not SAS. That doesn't work. You might be thinking, why? That's an angle and 2 sides. Why does that not work? Because the angle has to be in between the 2 sides, And to be in between the two sides, it has to be the angle that those two sides make. So basically, these two sides are part of the angle at D. And these two sides over here make up the angle at A. See what I mean? If you erase that line, you can see that the angle at A and D are made up of these two sides that we had. That angle is in between those two sides. When I say in between, that's what I mean. The angle is the angle that's formed by the two sides that were given. All right, so if you had these two angles, that doesn't work. The angles at B and E don't work because we don't have this side. Angle E is made up of these two sides, but we're given these two over here. Same with C and F, like I showed you before. It has to be A and D if you're given those two sides. And then that's enough to say if you have those three parts, then the other three parts automatically match up. That's enough to say that those two triangles are congruent. That's SAS. And that works. All right, here's another example of SAS. You could have this angle and this angle. If you have that angle, you would need two sides, and it would have to be this side and that side. It would have to be the two sides that are included in that angle. This angle is made up of those two sides, so you have to have an angle and the two sides that make up that angle. You don't need this side. It doesn't help you if you're trying to use SAS in this angle right there. All right, so it doesn't really, it's real specific on SAS. You can use any two sides, but it has to be that angle in between them. And if you have that, then you have congruent triangles. So there's two other ways to show that triangles are congruent, but I'm going to talk about that tomorrow. That's enough to get you started for today. SSS and SAS.